Hello and welcome to Lesson 3 in Unit 6 Exponent Laws in our Grade 11 University College math class. So today we're looking at powers with rational exponents. Now, normally I start this lesson by having you do an exploration with your calculator, this little part here we have at the top, which is 9 to the exponent 1/2 and then the square root of 9. And we go through this exercise and I teach you guys how to use your calculators properly. To be honest, there's not a whole lot of calculator stuff you need when you're actually doing the math in this unit. In fact, when we do this test, normally, or all the time really, we don't use our calculators for the final test because the type of numbers that we're working with, I go out of my way to make sure that they're manageable for you. They're not going to be some crazy, bizarre decimal numbers. They're going to be sort of on point. So, I guess what we learn at this very beginning stage is that when you have rational exponents. When we say rational, we mean fractions. So when we have a rational exponent here, a half, a third, and a quarter, what we find is that that's the same as taking either the square root, the cube root, or the fourth root of something. Now, I usually pause a moment and say to my students that in the same way that when I write the variable a, there's an invisible coefficient out front of 1, and there's an invisible exponent of 1, because if we have an a, we have at least one of them, so that explains the coefficient. And if we have an a, anything raised to the exponent 1 is just itself, so we don't bother to write it down, but it's there. In the same way that a is the same as 1a to the exponent 1, this symbol right here is actually not called a square root sign. You can use it to find other things than square roots. You can use it to find, as you see down here, third roots and fourth roots. So what's invisible in this is this little 2 that's right here. It's invisible because if we're taking the square root of something, we're looking for, at the very least, 2 identical numbers multiplied together to give you a product. So we don't bother to write it. Why? Because if we're taking a root of something, we need to have at minimum at least 2 numbers. So there's sort of a summary of our exploration, in that it is 9 to the exponent 1/2 is equal to the same as the second root of 9. And 64 to the exponent 1/3 is the same as the third root of 64. And 16 to the exponent 1/4 is the same as the fourth root of 16. So these things are equivalent. It's 2 different ways of writing the same thing. So we're going to learn a new notation today. Obviously this would be called the exponential form right here, because we've got a base and an exponent. And we're going to learn about something called radical form here today, which is a form that has a radical sign in it. So let's just talk about how to write this down. If you have a to the exponent m/n, what you'll notice is that the denominator, n, it goes in what I call the scoop, which is sort of like the little scoopy part out front here of your radical sign. So that n value, the denominator, goes in the scoop, and the numerator is still applied directly to our base. That's one way to write it. A second way, and this is my preferred way, so let's maybe put a little star on this one. This is preferred. This is the one that you want. Same thing, the denominator is still in the scoop, and the numerator goes outside the whole bracket. So really what I'm after by choosing this form preferentially is that when we're working to figure out what sort of the answer is, when we are evaluating these powers in either exponential form or in radical form, I'm suggesting that we do the root values before we apply the numerator. Sounds fancy. You'll see what it means when we get into some examples. So the first things first, let's write some notation here. Let's practice. So here we have x to the exponent 1/2. That's in exponential form. We want to put this in radical form. So I take my denominator, which is 2, I put it in the scoop, and I take my numerator and I apply it either directly to my base or sort of outside the whole thing. And as I said, this one down here, this is sort of my preferred version of this. You'll see why as we get further into our lesson here. So hopefully you've got this, at least sort of understand how the pieces work together. Let's now go and do one together. So here we go. We have a to the exponent 4/5. So let's get a radical sign happening. My base stays the same. It's the thing that goes under the radical sign. My denominator, hopefully you recall, goes in the scoop. And the numerator goes, I like to put it outside the whole mess. Although this one is equally accurate. the fifth root of a to the exponent 4. Now that's the last time I'm going to write it in that style. Again, if that's your sort of preference, understand that they are equal. You'll get the same answer when you calculate it. It's just I prefer the top version if we're not going to be using a calculator. And as I said, you'll see why. Okay, let's try C. Here we have 125 to the exponent 2 over 3. So let's get our radical sign happening. The base, of course, is 125. The denominator, it goes in the scoop. And the numerator, it goes outside the whole mess. There we go. Okay, so this is going from exponential form to radical form. Now we're going to try it in the opposite direction. So I'm going to give you something in radical form, and we're going to change it over to exponential form. So let's start with our base. Our base is going to be 12. And then we're going to have a numerator and a denominator. As you know, the thing in the scoop becomes our denominator. Now there's no visible numerator here. However, they wouldn't bother to write it, but it is on the outside of the whole expression, so that's going to be 12 to the exponent 1/3. Let's go try another one. So here we have the fourth root of 13, whole thing to the exponent 5. So my base is going to be 13. My denominator is the scoop, and my numerator is the value that's outside the brackets. So 13 to the exponent 5 over 4. Let's try one more. Actually, why don't we hit pause here? Why don't you try changing over this one? When you've got it, come on back, and then we'll see if you got it right. Okay, you're back. Let's get a look. So my base is going to be 17. My denominator is what's in the scoop, and my numerator is what's being applied to my base. So we have 17 to the exponent 3 over 7. So all that was about form. Let's head over into the next section, and we're going to start to work a few of these out. As you can see, there's a lot of them here. I've asked you to do them without a calculator. That's sort of the goal here today. So we're going to do the first row, and then we'll probably pause and start the second half of this video. So let's just jump right in. So here we have 16 to the exponent 1 over 4, and we're being asked to evaluate without using a calculator. So what I recommend first is to change this over to radical form. So 16 is my base, 4 goes in the scoop, and outside is that 1. Now you might be asking, how do I do this without a calculator? So here's how I would normally advise you guys to do it. Knowing that you're not using a calculator, the numbers that I'm going to use are not going to be complicated numbers with decimals and things like that. They're going to be whole numbers. So I would recommend that you try to just start with 2 and see if 2 works. So what I recommend is, again, you can do this in your head, but I would do 2 times 2 times 2 times 2. Because that is 2 to the exponent 4. Let's see if that gets us to 16. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer to the fourth root of 16 is going to be 2. So again, what I've replaced is the 4, or the fourth root of 16. So again, if it hadn't been 2, I would have tried the next whole number, and that would have been 3. And I would have tried 3 times 3 times 3 times 3. If it wasn't 3, I would have tried 4. If it wasn't 4, I would have tried 5, 6, etc. Only need to try whole numbers here. So we've done the root part. Now we need to apply the numerator. Now the numerator of our rational exponent is just a 1, so 2 to the exponent 1, of course, is just going to be 2. And that takes care of that. So let's try another example. Here's B. So B, we have negative 64 to the exponent 1/3. Let's change this over to radical form. So we have negative 64 as our base, 3 goes in the scoop, 1 goes outside. Now this should be sending out some alarms for you, because having a negative value under the radical sign is something where we normally go, nope, we can't go any farther here. There is no square root to a negative number, and that is true. However, if we're talking about odd powers, so something like a root of 3, or a root of 5, or a root of 7, or a root of 9, you can have 3 numbers that multiply together to give you a negative value. So that's going to be okay. So anytime you have an odd number in the scoop, you can work with a negative number under the radical sign. So let's figure this thing out. So as before, I recommend that you start with 2. So we're looking for a number multiplied by itself 3 times that leads you to negative 64. Whoops, that should be a 2. So 2 times 2 is 4, times 2 is 8. So 8 is not big enough. Next we'll try 3. So 3 times 3 times 3, that's going to give us 927. Also not large enough. Then we go try 4. 4 times 4 times 4 is going to equal 64, which is awesome. Now it's a negative 64, which means that each of these values needs to be negative. So let's just make sure that makes sense. Negative 4 times negative 4 gives us positive 16, and positive 16 times negative 4 gives us negative 64. So that's going to work for us. So the third root of negative 64 is negative 4 to the exponent 1. So again, what I've done is I've taken this piece, finding the root, the third root rather, of negative 64. It is negative 4, but I have not yet addressed that numerator on the outside, the numerator of our rational exponent. Fortunately, negative 4 to the exponent 1 is just going to be negative 4, with or without brackets. So we're doing great. Let's do one more example here before we shut this lesson down. So we have 36 to the exponent 3 over 2. Let's start by writing this in radical form. That's 36. 2 is my scoop number because it's the denominator, and 3 goes outside. So here's the reason why I always recommend doing the scoop value first before you do the 3. Here's why. So if I were to say, find the square root, or the second root of 36, we can all do that, right? We know that that's going to be 6, because 6 times 6 is going to be 36. And now when I'm in the position to do 6 cubed, you may not know that off the top of your head. 6 times 6 times 6 is 216. But we could definitely figure it out even if we wrote it out sort of long style. However, if we were to have done 36 squared, or sorry, 36 cubed first. So I'm going to get my calculator out. 36 cubed gives me 46,656, and I'm asked to find the square root of that. That is a much harder task to do without a calculator. I don't know how you would figure it out other than trial and error. So this is why the preferred method is to find the root first, rather than working with the numerator of our rational exponent. It's because the numbers get too big to do without a calculator if we don't. So you can see why in this example. So that's A, B, and C. That's the first half of our, just over maybe the first half of our last lesson in Unit 6. So come on back for part 2 and we'll finish this up.